So, all these things you can test, you will be learning in module 6. Then there is something called structural break in time series analysis. For example, suppose we are estimating a consumption function and where the time span is from 2000 to 2020, okay, for the entire Tamil Nadu population. As you know, in 2008 there was a financial crisis. Now, it may so happen that because of this financial crisis, the income consumption relationship might have changed drastically in the post financial crisis period. Okay. So, in that case, how will you test the structural stability in a time series data? And there comes the F statistic become handy. We will be using the F statistic suggested by famous econometrician Chow, which is popularly known as Chow test, to test the structural break of time series analysis in module 6. Then in module 7, we are going to discuss about dummy variable. Dummy variable. The example what we are discussing in this income consumption relationship is actually in this context both income as well as consumption, they are quantitative variable. But it may so happen that sometimes our variable of interest is not always quantitative. For example, let us say I am getting a model where yi equals to alpha plus beta 1 x 1 I plus beta 2 di plus ui. And what is di? Di, suppose now I am hypothesizing that apart from income, there might be significant difference in the consumption between male and female. So, that means I am hypothesizing gender might also play an important role in consumption. But gender is not a quantitative variable. The technique what we have learned so far, that is applicable only when your variable is quantitative in nature. But many times, as I said, our variable of interest would be qualitative in nature. Here is a case, let us say that you are interested to check whether gender has any impact on consumption pattern, or suppose you are interested in estimating an wage function and you are interested to check whether there is labor market discrimination, okay, across the gender. So, it might so happen that given the same amount of qualification, male workers are earning a higher salary than the female workers. So, that means there is a gender discrimination in the labor market. Okay. How will you answer those questions? Because this gender, then this gender, and it is basically a qualitative variable, right. So, qualitative variable you need to somehow make it quantitative one. How will you quantify? And there comes the dummy variable technique handy. You can easily define a variable d1i equals to 1 if male and 0 otherwise. Then you have converted your qualitative variable into a quantitative one, and you can apply the technique what you have learned so far in this context, right. So, this is how the dummy variable technique is very important, because many a times our variable of interest, some of our explanatory variables are qualitative in nature, and dummy variable converts that qualitative information into quantitative one, and that is what we are going to learn in this module 7, which talks about the dummy variable. So, we will give an introduction of the dummy variable, then we will discuss different types of dummy variable, ANOVA versus ANCOVA model. So, it may so happen that in your model you have only qualitative variable, that type of variable is called ANOVA model. Then we have ANCOVA model, which is basically a model wherein you accommodate not only the qualitative variable, but also quantitative one. Okay. So, that means a mix of qualitative and quantitative models in the variables in the model makes it ANCOVA, right. Then we will also learn about how to apply this dummy variable technique for impact evaluation. Okay. Impact evaluation, that is called difference in difference estimates, right. For example, let us say that your research objective is to check what is the impact of a job training on labor productivity. Suppose in your organization some of your employees have gone for a training, okay, a job training, and you want to see those who participated in the job training whether their performance has improved significantly compared to those who have not participated. That is called some kind of impact evaluation, and in the context of impact evaluation we will see how the dummy variable technique is quite helpful to estimate the impact of that particular policy. Then we will also discuss about seasonal fluctuation in this particular context. Sometimes it may so happen that the variable of your interest showing some kind of seasonal fluctuation. For example, if you are estimating a demand for, let us say, household utilities or home appliances, you will see that there are seasonal fluctuation, like in summer season there might be a drastic increase in the sale of, say, refrigerator and refrigerator, then air conditioning, so on and so forth. Then also in Diwali times, then in Christmas time. So in different seasons you will get some kind of seasonal impact on your dependent variable. So how will you identify those seasonal fluctuation? There also we will be using the dummy variable technique to estimate that type of seasonal fluctuation. And then we will also give you an alternative to chow test. So that means the structural break what I was talking about in the context of in module 6. So that means there we were estimating the structural break using the F statistic. A restricted versus unrestricted model we were estimating and then applying the chow test, that which is nothing but a F test. So that is a time consuming process if you apply chow test for structural break analysis. And chow test has several limitations also. In the process of estimating the structural break, you would encounter certain limitations. Those limitations of chow test would be overcome. We can overcome those limitations by applying dummy variable technique. So we will see how dummy variable technique can be applied to identify the structural break analysis. Then we will discuss about dummy variable trap, a rule which says that while assigning the dummy variable, you should include dummy variable which is one less than the number of categories. For example, here when you have number of categories are 2 male and female, I have assigned only one dummy. So it may, if you include dummy like this, let us say this is D1I and D2I equals to let us say 1 for female and 0 otherwise. That means I have 2 categories, I have introduced 2 dummies also, and you will end up with a problem which is called dummy variable trap. Okay. So here we will discuss what is dummy variable trap and what is the exact problem of dummy variable trap. So all these things would be discussed in module 7, right, in module 7. Then in module 8, what we will discuss is, this is module 8. So as we said earlier that before estimating the classical linear regression model, we assume certain things. Okay? We assume certain things. Why we assume certain things? Because those assumptions make the world idealistic, and in that ideal world only, if you estimate your function, the estimated coefficient will exhibit certain desirable properties which are unbiasedness, efficiency and consistency. But there is no guarantee that in real world when you collect a sample, you collect a data, your sample data will always follow the assumption what we make. Rather, most of the times some, at least one or more than one assumption would be violated, and if the assumptions of classical linear regression models are violated, then you no longer expect that your estimates will exhibit the desirable properties. Okay? They will not exhibit the desirable properties. And what will happen if the assumptions are violated? In that context, we will be relaxing three important assumptions: multicollinearity, heteroskedasticity, and autocorrelation. Okay? So, multicollinearity basically says when you include the variable, there should not be perfect linear relationship among the two variables, but in reality it may so happen that two of your explanatory variables are highly correlated. So, what will happen? What is the consequence of multicollinearity problem? How will you detect that your data is actually suffering from multicollinearity problem, and what are the remedial measures? If you are sure that your data is suffering from multicollinearity problem, then how will you rectify that problem so that your estimates they exhibit the desirable properties like unbiasedness, efficiency, and consistency. Then another important assumption, which is called heteroskedasticity, which assumes that error variance are constant. So, that means even if your x values increases or decreases across individuals, the error term for the ith individual or error term of the jth individual, the variance of the error term for the ith individual, variance of the error term of the jth individual, they are actually same. So, this is called constant error variance assumption, but many a times when you are working with the empirical data, you see the constant error variance assumption is actually violated. And in that situation we call it heteroskedasticity. Okay? Heteroskedasticity. So, we will again learn what are the consequences of heteroskedasticity, how to detect heteroskedasticity, and what are the remedial measures. And lastly, we will discuss about autocorrelation problem, particularly when you are working with cross sectional data, time series data. We assume that no two error terms, error term for the tth period and error term for the t plus 1th period should not be correlated. Okay? Should not be correlated, but in reality when you are working with time series data, many times we observe that the error terms actually show some kind of pattern. So, that means they exhibit some kind of interrelationship between these two between two time periods. So, error terms of two different time periods they get correlated, and that is what is called autocorrelation. So, once again, like multicollinearity and heteroskedasticity, in the context of autocorrelation we will learn what are the consequences of autocorrelation, and then what are the remedial measures, how to detect autocorrelation, and what are the remedial measures. Then this is going to be our last module, or module 9. Here we are going to discuss about qualitative response or limited dependent variable model. For an example, when we talk about the dummy variable, here we say that if you look at your dummy variable is an explanatory variable. So, this is called dummy independent variable. So, this is called dummy independent variable. That means some of your independent or explanatory variables are qualitative in nature, but it may so happen that your dependent variable y is also dummy. For an example, so that is why this y variable is actually called response variable. Response variable. That is why when your response variable become qualitative, that is called qualitative response model. Or this is also called dummy dependent variable. For example, let us say that we are interested to see what are the factors that determine whether the individual will have his or her own house or the individual will stay in a rented apartment, right? What I am saying, you are interested to see, to estimate the factors that will determine whether an individual will possess his or her own house or not. So, that means here your dependent variable also is qualitative in nature. That means possessing a house, you go to an individual, you ask, do you have your own house? The individual will say either yes or no. Yes or no. So, that yes or no response is basically a dummy kind of situation. So, that means yi equals to 1 if the individual has own house, 0 otherwise. Okay, 0 otherwise. So, in this context, our dependent variable itself a dummy variable, and that is why this is called qualitative response model or dummy dependent variable. So, the objective of these models is to estimate basically the probability of owning a house given the individual socio-economic and demographic factors. If I know the individual's income, if I know the individual's education, if I know the individual's age, gender, so on and so forth, what is the probability that the individual will own a house? So, 3 type of probabilistic model that we are going to discuss here, they are actually the linear probability model, logit model and Probit model. These are the 3 probabilistic model. Now, linear probability model is a model where probability of owning a house or probability of owning a car, that probability is linearly characterized, is a linear function of the explanatory variable. For example, probability of owning a house is, let us say, a linear function of income. That is the starting point of probabilistic model. But this probabilistic model LPM, it has several limitations. First of all, when you characterize probability as a linear function of x, that means we assume as income increases, probability of owning a house keep on increases, but that is a unrealistic situation. When your income increases from 10,000 to 20,000, 20,000 to 25,000, 25,000 to 50, 50 to 1 lakh, 1 lakh to 1 lakh 50, after some point of time, you will see that probability is not changing because it does not work in that way. When your income reaches to 1 lakh 50,000 per month, probably at that income range, everybody will have his or her own house. So, there is no much of changing in probability once you achieve certain level of income. So, that is why linear characterization of probability with explanatory variable does not give a realistic picture. It has several other limitations also. Because of that, econometricians, they have suggested 2 alternative models where the probability is a nonlinear function of the independent variables, and in that context logit and Probit model would be discussed. Okay. Then we will be discussing another important type of model which is called Probit model or censored model. Sometimes it may so happen that we are not interested in probability, rather let us say this is your yi equals to alpha plus beta xi, beta 1 x1 I plus beta 2 x2 I plus ui. This yi is, let us say, is your automobile expenditure. So, here I want to know, as income increases, what is the change in an individual's automobile expenditure? And if you recall your understanding of basic microeconomics, it is nothing but elasticity. elasticity of automobile expenditure with respect to income, right? When your income changes by 1%, what is the change in your automobile expenditure? So, what we will do, we will go to each and every household and we will ask what is your expenditure for automobile. But in that, let us say you are asking the question for 400 individuals. Out of those, let us say 100 individuals, they do not have any vehicle at all. So, if you say what is your automobile expenditure, then the data will become like this. Let us say this is 4 lakh, first individual say 4 lakh, then after that 3 lakh, then 10 lakh, then some individual will say 0, I do not have any automobile expenditure, then again 15 lakh, then 5 lakh, then again 0, 0, 0. So, your y, the dependent variable, will take the values like this. So, we will observe automobile expenditure only for those individual, who are actually having automobile. Others, since they do not have any vehicle, their automobile expenditure is 0. If that is the case, how are you going to estimate the model? Are you going to delete those observations with 0 automobile expenditure? And if you delete the observations with 0 automobile expenditure, then your estimate is going to be biased. So, that means this is a typical case of censoring. That means we have to censor our observations, our sample would be a censored sample. All the observations are, that means we have limited information on yi. Okay, we have limited information. This household we have information, this household we have information, but these two household I do not have information because they have 0. Again, these two household I have 0 information, that means limited information. So, when you have limited information on your dependent variable, but you have information for all the households regarding their income, gender, education, so on and so forth. So, we have limited information on dependent variable, but complete information on the independent variable. This is a case which is called censored regression model. So, we need to apply censored regression model characterized by a Probit model, okay, suggested by James Tobin. So, that is why it is called Probit model. So, we cannot simply throw out those observations with 0 automobile expenditure and estimate the model using the standard OLS technique that we learned earlier. If you do so, then your estimate will suffer from a bias. Okay? So, to overcome that, we need to apply censored regression model or Probit model. We will be discussing censored regression model here. And we will also learn about the difference between censoring and truncation. The truncated regression model is another important model. Of course, that model we are not going to discuss here, but at least we should know what is the difference between censoring and truncation. Censoring versus truncation. Okay. So, censoring means you have complete observation on x, but you have limited information on y. Now, suppose after collecting the sample, you do not want to include those observations with 0 automobile expenditure. Then what do? You delete this observation. After deleting those observations, your sample would become a truncated sample. Since you are not including non-ownership of a car in your sample, then your sample becomes a truncated sample of the population. Okay? And you need to apply the truncated regression model in estimating this, not the OLS, to get unbiased estimate. That is basically the difference between censoring and truncation. Mostly truncation happens in the pre-sampling period itself. So, for example, my objective is to estimate the elasticity of automobile expenditure only those households who are having vehicle. So, I will go to the individual, ask if you have a vehicle, then I will interview. If they say no, I will not interview the household at all. So, at the end of the day, I will have complete information on both y and x, on both y and x, right. I have complete information, but in case of censoring, I was having only complete information on x, but not on y. That is the difference between censoring and truncation. We need to understand in detail, and then we need to estimate, and again we need to interpret the coefficient. And these probabilistic models are quite different from the standard econometric model in terms of interpretation, okay, in terms of interpretation, because here you are going to estimate the probability of owning a house, okay. Then we will also discuss how the estimated coefficients are not a direct measure of marginal effect like the standard econometric model. And goodness of fit measure is also quite different in the context of probabilistic model as compared to the standard econometric model. Those things we are going to discuss in module in module 9, qualitative response models. So, linear probability model, logit and probit, they are called qualitative response model, while the Probit model is called limited dependent variable model. That is why I said qualitative response as well as limited dependent or Probit model, both the things will be discussed in module 9. So, this is going to be the entire syllabus of Introduction to Econometrics course. So, here our objective would be my objective would be to give you a brief overview of the subject to make a foundation in econometrics, so that you can apply your knowledge of econometrics in the real world whenever your interest is to estimate some kind of relationship between dependent and independent variable. And that relationship might not come from only from economics, rather it may come from any discipline, any other social science, even nowadays engineering and pure science discipline also they are applying econometric tool to estimate some kind of relationship. So, whenever you have some query about the causal relationship, cause effect relationship, and you want to estimate how much is the impact of the cause on effect, this is going to be useful. So, throughout this course I will take you to the theory as well as applied econometrics. So, that means you will learn theoretical portion as well as the application of econometrics using statistical software. This is going to be definitely an interesting and rewarding course. In a sense, there is a huge demand for this course in academia as well as industry. So, let us with this I am just concluding our introductory section. From next day onwards, we will be actually discussing all the subjects outlined in the course module by module. I wish you all the best in learning, and please put your effort, because this is the course which is quite different from others, little involved, it requires day by day reading and understanding, but if you do so, the amount, if you can invest time, the reward what you are going to get out of this course is huge. So, with this we are closing our discussion of introduction, outline of the course, and from next day onwards we will be actually discussing the subject matter module by module. Thank you. Happy learning.